To introduce radians, I start out by giving each student a little piece of a pipe cleaner. Looks like this. And I ask them to fold this piece of a pipe cleaner so it's exactly the length of the radius of the circle. Next, we're going to take a pencil or pen or something, marker, and we are going to mark this radius length around the outside edge of the circle. So place the pipe cleaner and kind of bend it around the outside edge of the circle and mark one radius length all around the outside edge of the circle. So now I have one mark that is a radius length marked around the edge of the circle, and I'm going to create an angle with this. We know that this is the length of the radius of the circle, and this, of course, is also the length of the radius of the circle. And this arc length is also the length of the radius of a circle, of this circle in particular. If we have an arc that is the length of the radius circle, the angle that cuts out that arc is called a 1 radian angle. 1 radian. Now we can kind of summarize this official definition now by writing like this. A radian is an angle that subtends or cuts out an arc in the circumference of the circle whose length equals the radius of the circle. Now, exactly how many radians are in a circle? Let's go back and mark some more. So picking up my pen and my pipe cleaner, I'm going to start with the mark I just made, fold the pipe cleaner around the edge of the circle, and make another mark. And then I'm going to take the pipe cleaner, fold it around the edge of the circle again, make another mark. And I'm going to continue until I've run out of circle. So when I'm done, you can see that I end up with 1, 2, 3, 4, 5, 6 radius lengths around the edge of the circle, which would correspond to 6 radian angles. So I can actually draw the angles 1, 2, so this would be 3 radians. If I go all the way to here, that would be 3 radians, 4 radians, 5 radians, 6 radians. How many radians do you think are in an entire circle? We've got a little bit left over. How much is that little bit? Well, it turns out, drum roll, that there are exactly 6.28 radians in a circle. Because I can mark 1, 2, 3, 4, 5, 6, and a little bit more radius lengths, and each one of those corresponds to an angle. Now, if there are 6.28 radius lengths in the entire circle, that means there are 3.14 radius lengths, or radians, in half of a circle. And you might think, oh, that sounds familiar. That's pi. You're exactly right, and this is 2 pi. So there are 2 pi radius lengths around the edge of the circle, which means there are 2 pi radians in 360 degrees. Now, you actually already knew this. You might not have known that you knew this, but think about this thing you learned in geometry. There's approximately 6.28 radians, or 2 pi radians in a circle. Well, every radian corresponds to 1 radius length. So think of the circumference of a circle. In the circumference of a circle, we have the little formula c equals 2 pi r, which is 2 pi times the radius. So there are 2 pi radius lengths around the circle. Therefore, there are 2 pi radian angles in 360 degrees. So 2 pi radians in 360 degrees. So how many radians per 1 degree? Well, if there are 2 pi radians in 360 degrees, we can just take 360 and divide it by 2 pi, or 360 divided by 6.28, and we end up about 57.3 degrees per radian. And when you look at it, you can see it does look like it's about a 60-degree angle, but just slightly less, because if it was a 60-degree angle, three of them would end up being exactly 180, but they're just three of them add up to be just a little bit less than 180. So 3.14 radians, or pi radians, is equivalent to 180 degrees, and 2 pi, or 6.28 radians, is equivalent to 360 degrees. Now you might wonder, why would we bother to make radian measures when we already have degrees? Don't degrees work perfectly well? Well, they do for a lot of things, but not for everything. So that'll be the topic of our next video.